structure that supports subsystem shall allow subsystem construction. Structure that supports the system. That orient the subsystem shall allow mirror to be oriented at the sun via the telemetry subsystem without obstruction. This is the structure that supports the system as well as the motors that orient the mirror. Subsystem shall allow for the mirrors to be oriented at the sun via the telemetry subsystem without obstruction. 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 Crucible. Okay, the subsystem shall allow for the mirror to be oriented to the sun via the telemetry system without obstruction, in addition to keeping unloading.
A long time. Because I was an idiot and put it all off until yesterday. Because I'm thinking, I have no class on Thursday. I have no other homework to do. I can do it all on Monday. I think that's the problem. I should be able to. If I start at noon, I can finish at 6.
Okay, who's online?
Finished at 1
Can you hear me?
I worked on it 13 hours straight.
Yeah, I can hear you.
Okay, good. Welcome. Anybody else online? Just one person. Okay, that's fine. Okay. So it looks like Keegan is online. So majority here is in class, so I may sometimes forget about you. So if you have a question, don't hesitate. Okay, Keegan?
All right, for sure.
Okay, good. I may completely forget about that. A few people online. Too bad. It's okay. All right. So we're gonna catch up what's left off in the last class. Last class was what? Wednesday. It was online class, wasn't it? Okay. So hopefully now you kind of get used to the system that if you don't feel like you coming here, you can still participate remote online. But as long as you are here, I have to take attendance. Too bad it's not me doing it. It's someone else forcing me to do it. You can complain to those people, but I have to do it anyways. Too bad. Okay. So everybody should have your sheet of paper with. Michael is actually became an avatar now, but anyways. Ready to go? Okay. Well, let me just start taking snapshot from here. They're taking like overview of the classroom. Okay, the classroom looks like this. Okay. Then I'm gonna start with Jack. Jack is what's this avatar? Anyways, it's a vomiting horse or something. Anyway.
It's supposed to be a weird dragon.
Good. Robot is Fox. Fox, yeah, Fox. And then Hunter is
Drawing skills of a deranged toddler with Alzheimer's. I mean, I can kind of see it. I'd say more like a donkey than a horse, but yeah.
What's it supposed to be? More like just a weird dragon.
It's beautiful. Hey, it's better than anything I can draw.
Order. Peter is a shark.
That's hilarious.
Okay. Anthony, detain. Caleb is a star. You have a piece of paper? You have to make one. Sorry. Just a minute. Okay, make one quickly.
Okay.
I'm gonna come back at you later. Before I come back, please make a. You know what to do, right?
Yeah.
Yeah, you can write on the
And
yes, banana man with top hat.
what's that out of the banana?
Banana man.
Steven.
Add a random picture of mine next time I show up to class.
Something between every single class.
And just see how my addictions in there.
I don't know, like maybe
I kind of didn't want to do a drawing, so I made my name super big, and I didn't really leave room for a drawing, but I can flip it over.
drawing like in the middle of it. You just need to remember to keep using red.
I could just like flip it over and draw it out. As long as it's red, I'll just say Sharpie. Red expo marker.
And
Yeah. As long as it's red.
okay.
It's gotta be red, because if it's in like red pen, it looks good.
Yeah.
Let me just double check. All right, attendance done. Let me just close the door. Okay. Let me double check that the lecture is recorded. Oh yeah, looks like it's being recorded. Okay, so let's just begin today. I'm going to start with updates as usual. Okay, so now I hope you understand how I communicate with you. That means it's not communication, it's just basically announcement. Announcement is announcement. It's not communication. I will tell you what to do. You have no argument. You don't have to even respond. That's announcement. So I use email for that purpose. And also, this is the origin of updates anyways. So if you are not sure, suppose you may have a very bad feeling, oh, wait a minute, maybe I'm missing something huge. You go there. Double check, make sure. Oh, phew, I can sleep today. So, yeah.
Sure.
Of an engineer.
Oh, okay. I get the
Oh,
point.
another day without sleep. I mean, to be fair,
So-
like 5 hours of sleep.
Yeah, it's so funny because, there's one student stopped by at my office. He's about to graduate. He's a senior, and he came in and said, oh, Dr. H, I took fluid mechanics, aerodynamics, and flight mech from you. Actually, one more, something like that. And then now, guess what? I got a job yesterday, even though I'm not graduating yet. Lockheed Martin Fort Worth, that was a dream job I always wanted. Man, I'm excited. Hopefully you can graduate, of course, but he's got a job. And then during the job interview, that was a round table style job interview. And then there are a bunch of people sitting the other side of your table. Interestingly, there are a few questions, very fundamental kind of questions. Hey, by the way, do you know Reynolds transport theorem? Could you explain what it is the best you can? Go ahead. Now, here's a question. Can you handle that today? Right here, at this moment? That is actually not even error. It's fluid mechanics. Let me just take the mask off. I'm sorry. Because I cannot see anything. So be ready for that kind of moment. This person got a job. How about you? Wait a minute.
That's debatable.
Let me, am I turning on my webcam? Hey, Keegan, can you see the classroom also?
Yeah, I can see the classroom.
Okay, and then you're
Wow.
looking at, yeah, you're looking at my desktop too, right? Okay, good.
Yeah.
Just checking. All right. Then I'm recording. Okay, double check. And suppose if the Microsoft server fails, it's not my fault. I'm sorry. Sometimes happens. Okay. So yeah, it's interesting. So I'm going to point out those important conceptual matters, such as suppose if somebody says, okay, Bernoulli's equation, casually speaking, oh yeah, I know Bernoulli's equation, p plus 1/2 rho v squared is constant. Now that's not it. Okay, those people may probably start asking you, okay, what's the meaning of 1/2 rho v squared? What is that? What's a dynamic pressure? What is dynamic pressure? Pressure actually, because of the kinetic energy you added on because you're moving, that is going to add the pressure on top of static pressure. That's called dynamic pressure. So what the hell is a static pressure then? Well, static pressure is the pressure. If you're not moving, you're going to feel that pressure. So atmospheric pressure, is that the static pressure? Oh yeah, of course. Can you carry that kind of conversation with those people? If not, you're not going to get any job. Period. Okay, you're facing the reality today. This is the real engineering. Probably starting today. I don't know. Whatever the classes you're taking, that was like a fake engineering. Well, shouldn't say fake engineering, but the pre-engineering. How's that? So, anyways, no compromise. But I'm here to help you out in any way you want to. In other words, communication. If you want to communicate with me, don't send me email. Okay, let me repeat. Do not send me email. I'm not gonna respond in real meaning. In other words, I'm gonna respond saying, hey, send me text if you want to chat, kind of respond. That's what you're gonna get. I'm not gonna respond back to emails, start arguing back and forth on email. There are a few people out there doing it, looks stupid, but I'm not gonna do it. Somebody knocked the door, I don't know. I'm not gonna open anyways, but because I took attendance, I can't. So please send Microsoft Teams text chat to begin with. If I'm online, you're going to get instant response. If I'm not online, you're going to get response anyways later. Then let's just get connected, chat, okay, show your desktop. I'm going to show my desktop. Let's solve the problem together until both sides completely agree and happy about it. There's no such a thing achieved through email exchange. email exchange usually gonna go in the wrong direction. Heated argument, more heated argument, fire back again. Hey, wait a minute, I'm gonna kill you. Wait a minute, wait a second, kind of thing. That's email. I'm not gonna do that. Only that those idiot people do those things. You're an engineer. Okay? So that's communication. All right, good. And the updates here. So updates is my announcement. So every time when I create a new announcement, I'm going to send you email. Basically what I'm doing is cut and paste. This portion is a new announcement, which is announced Wednesday, which is when? 2 days ago?
2 days ago.
2 days ago, yeah, okay. So I cut it, paste it, and sent you email 2 days ago. Did you receive it? I hope so. Okay. Now you can create the file folder inside of your Outlook saying, hey, this is AE301 updates. Then whenever AE301 updates email coming in, because there's always a title, AE301 updates. If you look at the title, slide in to AE301 updates file folder, then you can go there, always take a look at series of emails sent from Dr. H. You're not gonna miss anything. Then if you're not sure, just click on the link on top of each email, visit the original page, because this page is always up to date. That's what you're gonna do from now on, okay? Do not miss anything. That's probably the terrible way to lose your score. You just kick yourself so bad, you almost wanna die kind of thing, right? I'm not talking to anybody, but right? Okay, so don't do that. So this is how I communicate. As you notice, I bypass everything. What everything? The Canva, whatever people use. I'm not going to use that piece of shit. Well, I shouldn't say that. I'm not going to use that, except only 2 purposes. Number 1, grade book. You just go to Canvas, check your grade. Number 2, when you create teams, you use Canvas. Because you can really sign up, create your own team. That's not the team I created. I'm not going to take care of any internal battle. If you fight, go ahead, fight until someone dies. I'm not going to take care of it. That's why I'm using it. So only 2 purposes for the Canvas. Everything else, you go to this homepage. Especially updates page. This is important. Always refresh. Okay. So make sure everybody's crystal clear today. Okay. If you still get confused, please let me know. You feel super comfortable about what I'm doing. I'm trying to make your life super easy. You don't have to deal with that Canvas, whatever the software piece of something. You don't have to use it. I don't use it. I'm not going to use it unless they change it in a way I like. I'm not going to be controlled by software. I do tell the software company to change it because this is a piece of crap. I'm not going to use it unless you change it to make it more efficient, more user-friendly, more useful. That is engineer. Okay. Also another thing, solutions page, there's nothing in it though. As I correct your work and actually grade it, I'm going to start putting solutions except quiz 0. Quiz 0, I'm not going to give you solutions. But I gave you answer keys. Did you notice?
Yes.
Okay, let's just take a look at answer keys for quiz 0. Quiz 0, of course, you can access anytime. It's posted here. This is quiz 0, 14 pages of document, 7 problems. I hope you're working on it. How many people actually got right answers for everything? For everything. Everything. Nobody. Congratulations. Welcome to N1. So that means this is where you are. You have to have certain things to catch up from fluid mechanics. Unless you make this perfect, you're not done with fluid mechanics. If you do all of those problems done perfect in 1 hour, then I recognize you as, hey, you have mastery skill for fluid mechanics. Welcome to ERA. That's what you need to be doing right now, right here, at this moment. You have no time to do some major things over this weekend. Don't party, especially without mask, with like 50 people, hugging, kissing each other. You may be sent to jail, I don't know, after Labor Day weekend. Do you know what happened last year? Remember that. Don't do that. I mean, you are taking entertainment. I don't have any leisure time, of course, yeah. Unless you have a skill set of fluid mechanics. No one has. Okay, that's my expectation after Labor Day weekend. At least problem 1A and problem 1B, because I covered it in last class. And then the actual quiz 1A and 1B is going to happen soon. Be ready for it. If you don't work on quiz 0, problem 1A, 1B, there's no way in hell you can do quiz 1A, quiz 1B right. It's all up to you. If you don't want to do anything, just don't do anything. I don't care. This is your education. The only thing I can do is teaching. Learning belongs to you. If you don't want to learn anything, it's your problem. Okay? I cannot get into that personal level. So, problem 1A, problem 1B. Those are essentially the same problem. One is, I think, one is US unit, right? This is 1B. 1A is US customer unit. Obviously, US customer unit is units that, traditionally speaking, being hated by people who actually say, oh, I love US customer unit. I always use it all the time. You know, forget about SI. I'm not going to use it. Raise your hand. Nobody, right? Of course. And then people say, oh, I love SI unit because it's so straightforward. It's less confusing. That's not true. Okay? That's not true. You can make the exact same mistakes as if people do in US customer unit if you don't understand the concept of something that you run from last class. What is it? Somebody please tell me the concept that you run from last class. What is that? Go ahead.
Pound force, pound mass.
Pound force, pound mass is different, and also kilogram mass, kilogram force different. What kind of concept is that? Who made up that concept? Why do we need to have that kind of thing? Please tell me, somebody. Go ahead.
Because the concept of like a kilogram force and pounds mass is it's only for engineers. We don't, people who aren't engineers don't use it, so they're used interchangeably. So you need to know what you're actually writing down for someone else to read.
That's partially okay. I guess the most important thing is, okay, most people, unless those are one of you, aerospace engineers, most likely, they don't need to deal with different gravitational acceleration. Gravity means gravity for them. Gravitational acceleration standard sea level on Earth is 9.8 meter per second square, or 32.2 feet per second square. Those are essentially constant unless you are aerospace engineer dealing with high altitude, a rocket, and different planet. They don't need to use those things. So 1 kilogram mass of an object generates 1 kilogram force of weight, which is a force, under the standard gravity of 9.8 meter per second square. Same here, okay? 1 pound mass of an object create 1 pound force of a weight, which is a force, under the standard gravity of 32.2 feet per second square. So as long as you are in standard gravity, you don't have to differentiate those things. Okay? So now let's take a look at the problem here. Okay. An automotive tire with an internal volume of 100 gallons. That's, well, again, starting with non-standard unit to begin with. You cannot use gallons. What is the standard unit for the volume? Feet cube, because the length must be feet. That's the standard. They have to convert gallons into cubic foot. And inflate it to the gauge pressure of 32 psi. Wait a minute, what the heck is psi? Pounds per square inch. Is the inch? It's standard. No. You have to convert it to pounds per square foot. PSF. That's the standard unit. PSI is not. Make sure everything needs to be converted into the standard unit before you even punch the numbers in your calculator. Okay? So here's a Phoenix, and then 14.7 psi is the atmospheric pressure. Here we go. The gravity, oh, wait a minute. Gravity is not the standard happen to be. This is an all made up problem, of course. Gravity is 31.9 feet per second squared. Now what? You're going to start thinking about, okay, wait a minute. This is not the standard gravity. So pound mass and pound force is different. So now I'm talking about pounds here. Is this pounds mass or pound force? Oh my goodness, you have to tell that. This is the core component of this problem. Now, I hope you start to realize this is all about unit conversion, how to properly process your units. As an engineer, you cannot casually pick up your calculator, okay, 100 grams, 100 divided by 31.9, multiplied by whatever units. You can never get it right. And this happens all the time. So here's one important hint here. Make sure you listen to me. So just about, oops, sorry. Okay, sorry, let me just set it up. Monitor 2. Monitor 2. Okay, so I hope it works now. Okay, good. So, important hint today. So, engineering units in your analysis. This is a very, very, very basic principle. Whenever you do your analysis, of course, the numbers are always associated with some kind of units, and people give you whatever the units they want to give you. You, as an engineer, take whatever the number with whatever the units associated with, do the proper analysis, and spits out the units they want to have. That's your job. So it's always three-stage process. Number one, pre-processing. Number two, compute. And post-process. This is always what you need to be doing. If you skip one of those, you never get it right. As an engineering analysis, I mean, you're an engineer, so you're going to do engineering analysis, okay? You always do this. If you skip the process, there's guarantee you're going to make a mistake someday. And then that someday, somebody will die. Whose problem? It's your problem. You chose that, profession. You want to be an engineer, right? People give you responsibility if somebody dies, because it's your stupid mistake. And then if that mistake is a unit mistake, I'm not gonna make you pass for this class, at least. If you don't understand units, forget it. You're not gonna pass this class. You can take error from someone else. That's fine, but not me. So first of all, people give you the number associated with given units. Given units could be anything. So it could be, for example, PSI, okay? And then that person wants to have desired units. And that person don't care about you. They want to have answer in PSI. Okay, so remember this problem involves PSI, right? PSI everywhere. But you do know PSI is not standard. Inches are not standard. You have to convert inch into feet and make it pound per square foot, PSF. Because PSF is standard. 14.7 is a number associated with PSI, but you have to convert it to PSF. PSF is probably 2,118 or something. Huge number, that's why people don't want to use that PSF. 14.7 is nicer. 2,118 is too big to handle. That's why people use that PSI. There's a stupid reason associated with people use those units. It's like, oh, number is nicer. I use pound mass because number is nicer. It's like a 2-pound mass rather than slugs. Slug is 0.00001 slug. I don't want to use slugs because number is weird. I want to use pound mass instead. They don't care about if it's standard or not. You are the only one who needs to take care of it. So pre-process, first of all, as an engineer, you have to convert to standard. Always. Before you pick up your calculator to compute something, convert your units into all standard. Convert to standard. Then you know the standard. Mass is kilogram or slug. Length is meter or foot. Time is second. Temperature is Kelvin, Rankine. Stuff like that. You know those standard units. Now somebody now gave you inches. You have to convert it to feet. This is pre-process. Before you even pick up your calculator and punch those numbers into your calculator, you have to do this always, always, and always. Don't be lazy, because your laziness may potentially kill somebody in the future. You ruin your life. I'm not kidding. Because I saw multiple cases when I was working in industry. People died on welding robot. What was the problem? Oh, what a stupid mistake of engineer. Just one line is missing or something. People die because of your stupid mistakes. You may laugh at it right now on homework mistakes, and I give you second chance, third chance, but after you graduate, no way. Do you think people give you partial credit after you graduate? They will give you bill instead if you make a mistake. So let's just practice those things. So after you do pre-process, what happens? Now you pick up your calculator. The numbers are all lined up with a nice standard units only. So calculation is typically your calculator, or could be computation using computer, all standard units involved because you took care of it. Standard units only. Okay? So you're not going to use 14.7. You're going to use 2,118 because units associated with pounds, force, and then feet squared. Those are all standard. Then as you compute those numbers, you get the values, which is a standard unit value. Right? So after you compute, you're going to get the results of pressure, which is 2,500 pounds per square foot, because that's the unit you use. That's all standard. But your customer says, well, I want it in PSI. Then post-process is involved. You're going to convert standard units back into desired units. This is convert again. Convert to desired unit. Always do this. So this is the program that forces you to do this practice. Go ahead, question.
If the question is given in one unit and the answer is in the same unit, isn't there more chance of error by converting and then converting back?
No. Sorry about that, but I wanted to emphasize. No. So, okay, customer gave me PSI, and then they want PSI results out. So let's just use PSI throughout the computation process. No. Don't do that. Let me show you something. I think there's a handout of some kind. Let's just find out. I appreciate your question, by the way. So bad. So let's just take a look at one of the handouts. Maybe a handout, not this. This is someone's grandpa's handwriting. Sorry about that. Okay. Okay. So this is, interestingly, this is a fluid mechanics program. Here we go. Once again, I really appreciate your question. I wanted to emphasize this. So, question. This is, what's this, by the way? Anybody?
Barometer.
This is barometer. You can use this device to determine atmospheric pressure. In other words, atmospheric pressure pushes on the surface of this liquid, make this liquid level rise up to the height of h if this is heat vapor. This is barometer. So you know this right here, the pressure is about absolute zero. Although it's P vapor, but P vapor is so low. Let's just take it zero. This is the height. So by measuring the height of 400 inches, what is the PSI in P? Well, what is the PATM in PSI? Inches given. I need to give the PSI results back to the customer. Inches involved. So let's use inches in my calculation. That's the idea. Does it? Do you think it's going to work? Do you think it's going to work? Let's just find out. So this is the density of water, 2 slugs per cubic foot. This is nice because this is standard unit. This is the standard unit. So this is a standard. That's fine. Gravity, 32 feet per second square, standard. That's fine. This is not the standard inch. And then PSI, this is not standard. Both involves inch. But inch is consistent, isn't it? Let's just use inches in my calculator. Okay. So let's just use inch. Of course, you know, PATM is density of water multiplied by GH. What was GH? Hydrostatic pressure, right? You remember that? Okay, good. So density is 2 slugs per cubic, feet is involved. Let's convert it to inch. Right? Let's convert it to inch. I want to be consistently use inch because inch is given, PSI is wanted. Let's convert foot into inch. Multiply by 32 feet per second square. This is G. Let's convert it to inch again. So I'm using inches in my calculator, right? Multiply by 400 inches, which is given in inch nicely. Then what you get? 177.777 P. That's the value you're going to get from the calculator. Then this is supposed to be PSI because I'm using inches. Do you think so? My response is 177 PSI. Is it the core of nuclear reactor or something? This is way too high, insanely high pressure. This is not atmospheric pressure. If you are in 177 PSI, you're going to be squashed. This is crazy value, first of all. Do the sanity check, by the way, always. So what's wrong with that? But anyways, this is the way. Pre-process, number 1. If the inch is given, let me just finish, okay? You probably want to say something, but inch is given, but inch is not the standard. First of all, well, this is standard. Yeah, I'm going to use as is. This is, standard. Let's use it as is. This is inch. Let's convert it to foot. Then the result you're going to get is a PSF because you're using pounds and then foot because you're not using inch. Inch is converted to foot. Your result is PSF. So at the very end, you have to convert it to PSI. This is post-process, right? Pre-process is converted to foot, then compute, then post-process, process to PSI. So 3-stage process actually, you see. I converted inch into feet, compute it, and then result is converted to PSI. 3-stage process. Pre-process, compute, post-process. This is the one, hey, let's use inches in my calculator. One is, making sense. One is crazy wrong. What's going on here? Go ahead.
I believe since inches is like the not standard unit for the metric system.
Yes, you are right, but that's not the reason. You're right, inch is not the standard, but somebody used inch.
Yeah.
For this.
Due to
get this result. Why is that?
Due to that fact, it will produce numbers based on inches. If that makes sense. But
little bit more. Go ahead. Little bit more. You're getting close. Go ahead.
Units are whack.
Units of what?
Your inches cancel, your feet cancel, you're left with feet on the bottom and you're giving an answer. And then you multiply by
Okay,
inches.
okay, that's probably something similar to what Robert said. What's
Units of slug are different.
Oh, don't.
Because slugs are, they're made up of feet, not just inches.
By the way, this is the PSI. Is this a pound force or pound mass of PSI?
Pound force.
Pound force. What is the pound force? It's made up by what?
A slug per
Right?
slug by foot per second
And the
squared.
foot, not the inches. Per second
Yeah.
square. Go ahead. Go ahead, go ahead.
I was just saying that I'm recognizing that if you divide 177.777 by 12, you get the answer on the bottom.
That's right. So in other words, if you use inches to create the pound force, it never happened. If you want to create the pound force, you have to have foot. So you're using slugs, foot and second, automatically you create pound force. But not here, because you keep inches. And then, important thing, this is actually done by A students. They didn't even realize it. Because A students tend to stick with consistency. Oh, I'm going to use inches consistently throughout my computation. Should be all right. One huge number error. I don't know even what I did wrong. That is probably the typical moment somebody died. Because you don't even realize it. Right? That's why I say stick with this system. Pre-process, compute, post-process. Don't use inches because it's not standard in your calculator. Simply because somebody give you inches and then inch value back, you still need to convert it to foot once, then use that value inside of your calculator, and after that result comes out, convert it back to feet. You have to do that. If you don't do it and make a mistake, I'm going to frank you from this class. Period. Go ahead.
I'm just confused on, I thought if no matter what units you use, you should get the same answer. So where's the mistake in the example?
If you have a time after the class, we're going to go over more details. Let's just move on. We don't want to spend time here more. So I hope you get it, and then I'll chat with you, okay? Later. So if you still feel uncomfortable about this, I would highly recommend you just to come in and chat. I'm going to walk you through it. But most important thing today, of course, you have to tackle this problem. Okay? The real quiz 1A is going to come soon. And this time it's real. If you screw up, you screw up. This one is just a rough. Okay? So if you failed it, don't worry about it. You can pick it up. This is only 5 points. Quiz 1A alone is probably 20 points. Okay? If you screw up quiz 1A, the real one, you screw up. But this one, 5 points. You can pick it up easily. But be serious about trying to figure out this problem by yourself before the real quiz 1 comes up. If you don't do it, you're going to screw up. So number one, you have to seriously take a look at this problem 1A and 1B, because it's the same kind. One is SI, one is US unit. It's the same kind of problem. You have to seriously take a look at it, try to figure it out using nothing but just your fluid mechanics notes. Well, you can use arrow notes. So far, we covered something. So you can use those things. Or you can use my fluid mechanics, because it's posted free for you, the course homepage. Do whatever it takes. Figure it out. That's your skill. If you cannot figure it out, you don't have a damn skill. Who's going to give you a job? This is the skill set I need to see. At least I call you engineer. I'm not going to make you graduate if you don't understand units, because it's so dangerous. Somebody might die in the future. Most of the devastating accidents, mistakes are based on units. I would say probably more than 80% of the mistakes are units. Stupid mistakes. Oh, this was pound mass? Okay. Mistake. Okay, don't do that. So you have no choice. You either have to understand, or you're not going to go through this class forever. You can avoid me if you want to. I'm happy with that. Any question? So, by the way, what's your name? I'm gonna.
Dylan.
Dylan, okay, so let's just chat later, okay, make sure. All right, so I'm gonna go back to lecture. Let's just pick up what we left off. We talked about engineering units, it's so important. So this is the concept of gravitational unit system. In other words, if you are on Earth, you don't care pounds of pounds, kilograms, who cares about it? Not really, because you're aerospace. You have to literally differentiate. Every pound somebody gives you, you have to ask question, is this pound mass or pound force? Because I'm talking about 25,000 altitude, or I'm talking about moon, moon colony or something. Okay? You probably are the only ones, but you have to understand the unit completely. Otherwise, don't call yourself aerospace major. Okay? So take care of it. Problem 1A and 1B of quiz 0. Important. Okay? Don't ignore it. By the way, where is the answer key? Answer key is here. So click here in updates page. Answer key for the quiz 0 is actually given here. Those are the numbers. Actually, I always say the statement saying, well, those are the values that I got. So I may make a mistake. I'm human, although I minimize it. So don't trust those numbers 100%. There's no guarantee. Go ahead.
Can we go tutoring?
No. You can take this class from someone else if you want to.
Oh.
That's the only thing I can tell. If you need a tutor for AE301, you should probably change your major. This is not the class that tutors can help. I mean, who can help? Who? I mean, probably almost graduating senior, they're freaking busy. They're not gonna have time to spend with someone. Face yourself. Either you build your own skill or you give up engineering.
And
now is the semester I'm talking about. Okay, go ahead.
what about office hours?
Of course you know my office hours. I'm open.
I mean, for put it 0.
You figure it out because I'm telling you. Okay, do you read this page?
Yeah.
Do you read this page? What does the page say? You have to figure it out all by yourself. That's what I'm saying.
Okay.
I'm not going to give you solutions. That's what I'm saying. But I give you answer keys so you can check against those numbers. That's the only thing you can do. Go back to fluid mechanics. This is, by the way, not the aerodynamics. This is a fluid mechanics. I expect you to have a skill already. Don't ask me to help for that. You build yourself. Then you come to aero. Go ahead.
Do you have a specific policy for the precision on answers
Ah.
that you would like to see?
Oh. If you compare against those answer keys, right? If it's like a plus minus 5%, yes, yeah, okay, I think. Yeah, it's a total. Anything else? Take it seriously. Read it. Okay? Some of you may have a wrong idea about this class. Fix it. Right here, right now. This is engineering. If you seriously want to be an engineer as you graduate, you need to go through this. Okay? There's no place to hide. Either you get the skill, do everything all by yourself, or you have plenty of other options. You don't have to stick with me. Any other question? Okay, let's go back to notes. So get that? This is the engineering units. Do you have any more concern, confusion about units? Please, let's just make it crystal clear at this moment. Because as I move on, engineering units is done. I expect you mastering engineering units completely. If you have any kind of confusion, please tell me now. Don't hesitate. Go ahead.
So KPA, like,
KPA.
what units is that in? Because it's similar to PSI or PSF.
KPA is like
Kilopascal.
kilopascal. 1,000 Pascal. Pascal is Newton per meter square. Actually, that's a great question. Let's move on because we're going to talk about that. Here we go. Next page. Page 4, okay? So you're talking about Pascal, which is this, okay? Great. I appreciate your question. This is Pascal, Newton per meter square, PA. Oftentimes used Pascal. This is actually standard unit. So kPa is a kilopascal, which is 1,000 Pascal. Now those are the only applicable for SI unit, right? C is a centai, and the M is a milli, and kilo is 1,000. Okay, so kilo is 1,000, centai is 100, milli is what? No, milli.
It's
What are
1,000.
This is not. This is divided by 100 or something like that. You know those things, do you?
Yeah, centi
Centai is 1/100. Milli is 1/1,000. So suppose if you give me 1 millimeter, it's 0.001 meter. You have to convert it back into meters, right? 1 kilometer is 1,000 meter, something like that. So kilopascal is 1,000 Newton per meter square. So if somebody gives you, of course, kilopascal, that kilopascal need to be converted back into Pascal to begin with, okay? So those are the units we have to deal with in AE301, pretty much. So you see that the pressure, density, temperature, this is the gas constant for air, standard air, okay? Standard air. 5 more minutes. So the unit, as long as the unit's concerned in this class, I try to avoid the mishaps. Of course, fluid mechanics, I intentionally try to confuse you. So giving the problem using pound mass instead of slugs, trying to give you a program PSI rather than pound per square foot. I intentionally do that. I try to avoid it in this class, except first quiz. Okay? So those are the standard units. Pascal, this is what? PSF, pound per square foot. Okay? This is the slugs per cubic foot. This could be pound mass over cubic inches. That's terrible, isn't it? You have to convert it to slug into pound, well, pound mass into slugs and inch into feet kind of thing. But I'm not going to usually do that. This is a kilogram per meter squared. This is the raw density. This is the temperature, Rankine Kelvin. So this is the conversion of the temperature. This is a standard suitable atmospheric pressure, 2,116 pounds per square foot. This is actually 14.7 psi. People actually want to use that instead because 14.7 is much nicer number. Okay? But in aero, I try to stick with standard units almost always, except the quiz 1. So you have to be careful and then do your best shot. Prove that to me that you understand how to use engineering units. Stick with standard. That's what it is. Okay. So those are the conversion, feet to meter, pounds, force to Newton. This is a mile to feet, hour to second. This is miles per hour to feet per second. Feet per second is standard. This is not. But oftentimes people give you miles per hour all the time. So you have to convert it. This is a quick conversion. Okay? The rest is a standard units for aerodynamic properties. Okay. So let's just stop here today. Do you have any question? Go ahead.
So you said quiz 1 is only 1A, 1B?
Wait until I announce it.
Okay.
I'm going to announce it specifically, so wait until then. But the quiz 1A is going to come in soon.
Okay.
So be ready. So you continue working on quiz 0, problem 1A and 1B. That's all I'm saying.
Okay.
Any other question? Go ahead.
Will you be telling us about the other problems for quiz 0 for our quiz 0?
Another problem what?
Like on quiz 0, there's more than just 1A, 1B.
Of course. You just keep working on those things. And then after quiz 1A and 1B, quiz 2 we're going to show up.
Which will be on problem 2 of quiz 0.
So quiz 0 is important. Even though you did horribly, you have to keep working on it. Go ahead.
So as the subsequent quizzes come in the semester, once quiz 2 comes around based on problem 2 on the first quiz, will the material on that be covered in class naturally as we progress through the semester?
You're right.
Okay.
Yeah. So stay tuned. Pay attention. Ask questions. Go ahead.
Homeworks.
Homework. before you go, let's just quickly take a look at the homework things. Homework. Okay, homework you can download from course homepage, right? And number is weird, isn't it?
Yeah.
This number A11 corresponds to the notes in-class example numbers. So since we are done in-class example A11, you can now work on homework A11. Suppose if I complete class example A12, you can now work on A12, A, B, C, D, E. Those are all based on example A12. So you keep your pace. Do not wait until I said, hey, turning homework tomorrow noon, turning homework of unit A3, and then, oh my goodness, I have to get started, it's too late. If I cover something in class, make sure you work on homework. Homework due dates will be announced. Usually, typically right after I complete each unit. But do not start after I announce homework due date. It's usually too late. Okay, so homework numbers are associated with class example numbers. So keep up yourself, continue working always. Go ahead.
And are we just using like our own paper for this one, for homework?
Homework, you need to download and use the worksheet from the course homepage. I'm not going to accept anything else. Either you can do it digital ink or print out on paper, turn it into PDF, either way is fine. Listen, take a look at this. Important. You are missing some information. Very important. Here, how to submit. Please read this document. Okay, this document tells you all. Option A and B. Print out each worksheet on paper or download and use digital ink. Either way. It's your decision, but I would recommend you traditional style. Print out on paper, work on paper, and then take a snapshot, turn it into PDF. Any other question? Have a good day.
Thank you.
All right. See you next week, Wednesday. We don't have class on Monday.
Professor, do you have a class now?
Yeah, I got a class. So you can connect up. Okay. You can connect up using Teams. I have a class right here, but I'm here.
The ones on your home page. Sweet.
I mean, I cannot prohibit it.
Yeah.
Yeah, see ya. You can do whatever to solve those problems. You can grab any material if you want to. You can use your notes. That's probably better for you because it is going to force you to kind of figure it out with limited resources, but rather than just Google to find out. But yeah, but you have to figure out the solution. That's the point. Okay. So I'm okay as long as you understand it. Okay. Which slide? Again, which slide? What slide? Which slide? What is it? Using what slide?
We're going over last slide.
No?
Yeah.
That's on homepage.
Okay. Thank you. I was just thinking.
No. Wait a minute. That's something missing. You have to read the document. I told you to read. You have to start from there. So
We did, yeah. We did. So, yeah, we sent you that, yeah, but we're just formally. That's it, right, right. And then Matt.
It's in Teams, I think I put something on last night.
We'll send you more formal.
Yeah. I just marched. I don't know. I like it's a lot of work. I'm gonna start on homework this on Wednesday. Just try to start.
We got a lot of homework to do. Got this. Not Arrow yet, not at least, not yet. Dynamics.
But yeah, like it's radical.
Dude, rad. The guy, but his homework. That's not. It always has the due date on the paper. For sure. And I was a little bit early to ask how you feel about ACC.
This weekend, we're probably gonna. All the ACC stuff is.
Back is muddy.
Yeah, I gave it a week to study.